Classification of signals. Classification of signals. Signals are majorly classified into 6 types. Continuous time and discrete time signals. Even and odd signals. Periodic and aperiodic signals. Deterministic and random signals. Energy and power signals. Causal and non-causal signals. Okay, so this is the classification of signals. Now let me start the first one. Continuous time and discrete time. Continuous time and discrete time signals. Coming to the continuous time, it is represented by x of t. It is said to be continuous because it exists for all t, or I can say it is defined for all t. It has values at every value of t. Okay, suppose take this example. It has value for every t. This type of signal is called continuous signal. Okay. All the naturally occurring signals are continuous in nature. Speech signal means the voice signal is continuous, is a naturally occurring signal. Like some seismic signals, some astronomical signals. The signals present in the atmosphere or they exist in the atmosphere naturally are said to be continuous. The other name for continuous is analog. Analog. Okay. Coming to discrete. Coming to discrete. The discrete signal is represented by x of n, where n is discrete. Discrete means it has values at, or it has value at specific intervals. Okay, not continuous. N is not continuous. Then how to get discrete signal? Discrete signal is not a naturally existing signal. Discrete signal has to be generated. How to generate a discrete signal? It can be generated from a continuous signal. So take one continuous signal, then after sampling the continuous signal, you are going to get your discrete signal. Okay? Discrete signal can be obtained by sampling the continuous signal. What is meant by sampling? What is sampling? For the understanding purpose, you can take the sampling as simply cutting. Let me explain by taking the same signal. Suppose take the same signal. The signal is like this. Okay. Now cut the signal. Cut the signal. See the signal. Well, simply, yes, sample your continuous signal. Means we made cutting for the continuous signal. How? It is 0. It is 0. At every TS, you have to cut your signal. TS, then cut at this point. TS, then 2 TS, then 3 TS, 4 TS, 5 TS. Here it is minus TS, minus 2 TS, etc. This value, this TS is common, but the varying thing is this integer value. This integer value is represented by n and it tends to infinite because it's a continuous signal. Continuous signal tends to infinite. Then converting this continuous signal like this is called sampling, and now this signal is represented by x of n. So the axis here is, now it is n. Okay, see the difference? Here the signal is existing for all values of t, but here the signal is not existing for all values of n. It is existing only at discrete intervals. And remember, this cutting must be at equal intervals. Okay, at every TS you have to cut the signal. So you can write your discrete signal as x of n is equal to x of n TS, where n tends to infinite. What is TS here? TS is called sampling interval. TS is called sampling interval. Okay, I think you understand how to convert a continuous time signal into discrete time signal. Simply you have to consider a sampling interval, you have to choose a sampling interval, and at every sampling interval you cut your continuous signal, that is called sampling. Okay. Thank you for watching this video. If you like this video, please don't forget to like, share and subscribe.